Okay, in our first video, we learned that differentiation means slope. So when we differentiate a function, we are finding the slope of that function at any given point. Now, in terms of the rules for differentiation, the last video looked at finding the derivative from first principles. In this video, we're going to look at our basic rules. So similar to functions, in functions we have several different ways of representing a function. We can say that f of x is equal to our function, or we can say that y is equal to our function. That's just two of the different ways. Differentiation is the same. In first principles we looked at the derivative as being f dash x, whereas when we're looking at y is equal to something, our derivative is represented by dy dx. Now what dy dx means is the rate of change of y with respect to x. So this is where our link with slope comes in. So the rate of change. Rate of change does mean slope. So we're looking at the rate of, so how y changes with respect to the x. So that's what dy dx means. dy is short for delta y, delta x. So rate of change of y with respect to x. So when we're finding the derivative of any function, we can use either of these two notations and they will be fully correct. So in terms of our basic rule, so we looked at our basic rule from the perspective of differentiation from first principles. Now we're going to look at a bit of a shortcut. So where we have a function y is equal to x to the power of n, so x to any power, our derivative dy dx is going to equal nx to the power of n minus 1. So in English terms, just to make it easy, we bring down the power and multiply, then reduce the power by 1. So some people find it easier to look at the rule in English terms first, and this is exactly what we're doing. So we bring down the power to the front of the function, so that's where our n in front of here comes from, and then we reduce the power by 1. So if we look at some basic examples where we have y is equal to, for example, x squared. When we're looking at dy dx here, we're going to bring down the 2, so the 2 comes down and is multiplied by our original function, and we are going to reduce that power by 1, so that becomes 2x to the power of 1. So once we get used to it, we can skip this middle step here and go straight from our function to our derivative. If we look at y is equal to x cubed, we apply the same rule. dy dx is equal to, so the 3 comes down and we multiply it by our original function, and then we reduce that power by 1, so that becomes 3x squared. All right, so what we can see here is we can see a little bit of a pattern. If we are differentiating a quadratic function, it becomes linear. If we're differentiating a cubic function, it becomes quadratic. So it always becomes one step down. So the slope of a function is always one step down from its original function. So just before we go on to more complicated rules, I just want to look at what happens if there is already a number in front of the function. So in this case, dy dx, remember the rule is bring down the power and multiply. So because we already have a constant here in front of our x, we have to multiply the 3 by the 2 to get our new number. So 3 multiplied by 2 gives me 6, and then reduce the power by 1, that becomes 6x squared. Okay, so again, we can see that a cubic function becomes a linear function. All right, now there's two functions that I didn't look at in terms of finding their derivative, and we'll look at them now. So we spoke about cubic functions dropping down to becoming quadratic, and we spoke about quadratic functions dropping down to become a linear. But what happens in linear functions? So for what happens, for example, if I have y is equal to 2x? Now, if we were to look at a graph of that function, y is equal to 2x, it would be a straight line. We know that the slope here is 2 because it's in terms of y equals mx plus c. So we have a straight line with a slope of 2. All right, that in itself should give us an indication of a bit of a clue in terms of what the derivative might be, because remember the derivative is the slope of a function. But in terms of our basic rule, dy dx, we are going, so in our power here we have, if there's no power present, that means we have a power of 1. We bring down that power and multiply, so 1 times by 2 gives me 2. And if we reduce that power by 1, we get 2x to the power of 0. So from our index rules, we know that anything to the power of 0 is just 1. So really what that is 2 multiplied by 1, which is just 2. So the general rule for differentiating a linear component or a linear function is simply to keep the constant in front of the function and we simply drop the x. So if we were differentiating 3x, for example, that would become 3. 4x would become 4. So all that happens, because the 1 is simply going to reduce down to a 0 in terms of the power, anything to the power of 0 is 1. All that happens is we drop the x. So that's linear functions. The other type of information that we have to look at is, what about if we have a constant? So if, for example, we have y is equal to 3. Again, if we were to look at a graph of that there would actually be a straight line. So the function y equals 3 is simply a horizontal line. The slope of a horizontal line is 0. So therefore, anytime we have a constant, the derivative of a constant is going to be 0, because the slope of that function is 0, right? Another way of looking at it is if we were looking at, I think that's the easiest way to look at it. So anytime you're differentiating a constant, that constant simply becomes 0. Now, in terms of normal functions, we normally have a function with several different components. So if we look at a quadratic function, for example, so we're going to look at the function 2x squared plus 5x minus 7. Now, when we're differentiating something like this, we actually break it down and take each part of the function one part at a time. So when I'm finding dy dx here, I will first of all concentrate on the 2x squared. We bring down the plus in the middle. Then I'll concentrate on the 5x, then I'll bring down the minus, and then we'll concentrate on the 7 at the end. So applying our rule, bring down the power and multiply, reduce the power by 1. We're going to have 2 times by 2 gives me 4x to the power of 1. We can put in the 1 if we want there, there's no problem with that. This is a linear component, so we drop the x, or 1 times by 5 is 5x to the power of 0, x to the power of 0 is 1, so that's simply a 5. And a constant simply becomes 0. So our answer to this would be 4x plus 5. Let's try another one. If we have y is equal to 3x cubed plus 7x squared minus 4x plus 5. Let's look at differentiating this. Again, we take it one step at a time. So if we're looking at the 3x cubed, 3 times by 3 is 9. That's 9x, and reduce the power by 1, so that's 9x squared. Write down our plus sign. 2 times by 7 is 14, so that's 14x to the power of 1. Write down our minus. 4x becomes 4, and the 5, a constant, becomes 0. So our dy dx is 9x squared plus 14x minus 4. So that's our basic rule. So remember your basic rule for differentiation: bring down the power and multiply, then reduce the power by 1.